Hi. I noticed that the Emeritus Professor of Mathematics at ANU, John Hutchinson, quite recently, in 2019, put up a document on the net. It's Leaving Certificate Examination 1962 Mathematics 2 Honours Paper, and he's worked the solutions and comments in a 28-page document. It's 29 pages if you include the first page. Let me look at a very, very tiny part of this for today. I'll just look at question 1.1. So this is probably one of the simplest questions on the paper. He's written up an equation and he's asking you to prove that the left-hand side is equal to the right-hand side. The equation includes complex numbers. The proof that he provides is quite simple. It's completed in a couple of lines. So it's probably one of the simplest workings in the paper. The reason I'm looking at it is I'm thinking of a very primitive approach to looking at this material is not to do any advanced algebra, even advanced by high school standards, but simply to think of doing a spot check by substituting particular value on the left-hand side, doing the calculation and seeing if you get the same answer when you substitute that value on the right-hand side. In fact, there's only one variable in this equation. It's n. So we can experiment with different values of n. For example, we could have integers, real numbers, perhaps complex numbers. So that's the idea of the exercise today. How far this will go, I don't know. Certainly, if I look at the paper as a whole, it requires an advanced knowledge of high school mathematics in order to do the solutions. And we might speculate that an advanced knowledge of high school maths is all that one should be required to have in order to understand any kind of mathematical presentations. We might assume that if things can't be explained in language that's intelligible to advanced high school, that maybe it's simply obfuscation, which is a word used by Alan Turing in a lecture that he gave in 1950.